Hey, welcome to the Explainer. So, you've probably heard the word algorithm thrown around a ton, right? But what does it actually mean? Today, we're going to treat it like a puzzle, and I promise, by the end of this, you'll have the key to solve it.
Okay, so what in the world are we looking at here? At first glance, this just looks like a bunch of nonsense. A random jumble of words, numbers, symbols. Is it some kind of secret code? Notes from a mad scientist? It almost seems like it's designed to be confusing.
Right. So what does any of this actually mean? That's the challenge. But here's the secret. We're not trying to crack a code. We're just trying to organize a process. And the best way to do that is to break it down. This whole thing, it's really a puzzle hiding in plain sight.
So, let's do what you do with any puzzle. We're going to tackle it one piece at a time.
All right, first up in our little drama, we need to meet the cast of characters. Or, in this case, let's call them the scorekeepers. Every process needs a way to track what's happening, and that's their job.
So here they are. We've got our three key players. Counter is just the total tally. It tracks every single item we look at. Then you've got accept and reject. Pretty straightforward, right? They're the two possible outcomes. And notice, they all start at 0. A totally clean slate.
Okay, but what is this whole system even looking at? Well, that's the input. For our puzzle here, the raw material is just two simple measurements, the length and breadth of an object. This is where it all begins.
And you know, if input is where we start, then output is the grand finale. It's the whole point. After all the dust settles, the system just tells us the final scores for accept and reject. That's it. That's our goal.
Okay, so we've got our scorekeepers, we've got our inputs, and we know what the output should be. But how does it actually decide? Well, that's where the decision engine comes in. This is the brain of the whole operation, the part that makes all the calls.
So here we go. The first gate. An item comes in and the system asks a really simple, really direct question. Is the length greater than 30? And the answer can only be yes or no. That's it.
And if it gets past that first check, it hits another one. Is the breadth greater than 30? Again, it's just a simple yes or no. You can kind of see the pattern emerging, right? It's just a sequence of logical hurdles. And then there's one last test. But this one's a little different. First, it has to do a quick bit of math. It takes the length, multiplies it by the breadth, and gets what it calls size. Then it asks, is that new number, that size, greater than 600?
And boom, that's the entire logic. Right there, it's not some kind of dark magic, it's just a super rigid but perfectly logical series of questions. An item's fate is sealed based on how it answers these three simple checks.
All right, theory is one thing, but let's actually see this machine in action. We're going to feed it a couple of items and just watch what it does.
Okay, here comes our first package. Length is 40, breadth is 20. Let's run it. First check, is the length greater than 30? Yep. 40 is definitely bigger, so it moves on. Second check, is the breadth greater than 30? Uh-oh, no, 20's not. And just like that, the process stops dead in its tracks. This package has failed.
So what happens? Our reject scorekeeper gets to work. Click. That reject count just went from 0 to 1. We have our first result.
Okay, next item up. Let's imagine one with a length of 40 and a breadth of 35. Let's run the checks. Is length greater than 30? Yes, it is. Is breadth greater than 30? Yes, it is. Okay, final check. We calculate the size. 40 times 35 is 1400. Is that greater than 600? Oh yeah, absolutely. This one is accepted.
And just like that, the accept scorekeeper gets its moment. Click. The count goes up to 1. You see, the system is just chugging along, doing its job perfectly.
Hey, remember that weird piece from the very beginning? The bit that said counter greater than 10, stop? Well, that's basically the off switch. It tells the whole process to stop after it's seeing 10 items. And after running those 10 items, here's what we get. This is our final output. 2 accepts and 8 rejects. This bar chart, this is the whole story of our process.
So, let's recap. We started with what looked like a complete mess of text. We figured out who the scorekeepers were, what the inputs and outputs were, and we reverse engineered the decision engine. We even tested it and got a final result. So now,
It's time for the big reveal. Let's put a name to what we've just been doing.
What we just picked apart, that is an algorithm. That's all it is. It's not some kind of sentient AI, it's not magic, it's just a finite set of really clear instructions, a recipe, a flowchart, a series of yes or no questions designed to solve one specific problem.
So our little abstract puzzle, it actually has a very real-world job. We basically just designed a simple quality control algorithm. You can just picture a conveyor belt in some giant warehouse automatically sorting packages by size. That's exactly what this set of rules is doing.
And this is why this whole thing matters so much. Our package sorter was really simple, right? But the fundamental idea, a set of rules, inputs, and outputs, is the exact same logic that powers these incredibly complex systems all around us. The algorithm that decides what pops up on your social media feed, the one that finds the absolute fastest route on your GPS, or the one that recommends a book it thinks you'll love, they're all just way bigger, way more complicated versions of what we just walked through.
So, we've seen how just a few simple lines of logic can sort physical packages in a warehouse. It really makes you stop and think, doesn't it? What other invisible rules, what other algorithms are out there right now shaping your world? Sorting the information you see, the choices you make every single day?